Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Hi guys, Madam Mariam here. Welcome to the first chapter of PHY260, which is geometrical optic. So today we are going to learn about ray model of light, reflection and refraction, total internal reflection, dispersion, thin lenses, locating image, as well as the thin lens equation and also mirrors. So I am going to cover what light is first. As we all know, light travels in a straight line or path called as light rays. So how do you draw a light rays? Basically, you simply draw a straight line with arrow to show the direction of light. So we will see later on, once the light hits a surface, what will happen to them. Now, there are many types of beams. So those arrows of light just now that you've drawn, that will be the beams. We call that beams. So the types of beam that we have are parallel, divergent, as well as convergent beams. And light for an object either result because the object is emitting light or light is reflecting from the surface of the object. For example, look up in your room. Of course, you have light sources everywhere, such as on the wall, on your phone, and so on. So those light are caused from electricity. So these sources of light are emitting them. Whereas light can also be seen if it is reflected on a surface. For example, I have a pencil here. So when I place the pencil in a dark place, the image of the pencil is slightly blurry, or I can't really see the pencil very clearly. So what I do is I switch on the light. Why do I need to switch on the light? It's for me to see the image clearly, or for me to see the pencil clearly. This is because, let's say I have a light source here. So the light will be directed towards this pencil, and of course all the surfaces of any objects in the room, and it will be reflected. So wherever it hits, okay, so those light will be reflected back into your eyes. So that's how you can see those images or those objects around you. For example, as you can see a cute cat here, the cat is looking at the light source. Now, why can you see only the head of the cat, not the whole body? Can anyone answer? Correct. Because the light source is only hitting on the cat itself, not anywhere around it. The power of the light is not strong enough for it to be reflected off further, for it to be projected much further beyond the cat's distance. So from here, the light will be reflected into your eyes. So that's how you can see the cat's face, which is directly above the light source. Now, let's go to reflection and refraction. I've mentioned reflection many times before. So what does it mean by reflection? A reflection is when a light hits a surface and is reflected back at a certain angle. So according to the law of reflection, okay, where it hits, that will be the angle of incidence. So for example, light is coming from here, okay, it hits the surface, and the light ray or the path that it goes through will create an angle between the normal to the surface and as well as the light ray. So normal to the surface is just simply a line that is perpendicular to the surface where the light hits. So now that the light goes on the surface, of course it will be reflected back at exactly the same angle. So if I have an angle of 30 degrees here, if my angle of incidence is 30 degrees, my reflected angle will also be 30 degrees. So this is called my angle of reflection, or theta r. Now, according to the law of reflection, like I mentioned just now, the angle of incidence must always be equivalent to the angle of reflection. So this is the law of reflection. But this only applies for a perfectly smooth surface. And the law of reflection also states that the incident ray, the reflected ray, and the normal to the mirror at the point of incidence all lie on the same plane. What does it mean by this? First of all, we have to have a plane surface or a plane mirror, because the surface has to be smooth. So on top of the surface, let's go to the previous slide. So on top of the surface just now, we have the incident angle, which is theta I. We have the normal to the plane, which is perpendicular to the surface, as well as the reflected ray, where it creates the angle of reflection. So all three must be on the same plane or the same surface. That will be the second law of reflection. Now let's go to the types of reflection. There are two types of reflection, specular as well as diffuse. I've mentioned before that reflection angle of incident as well as the refracted angle will only be the same if it hits a smooth surface. So this is either called a smooth surface or a specular, where it undergoes a specular reflection. But if the surface is not smooth, it's a rough surface, what will happen is the reflected ray will go on all different kinds of direction. So this is called diffuse reflection, where the light will go in variety of direction and to any position of the eye. Let's give an example here. If the angle between an incident ray and the plane mirror is 40 degrees, so I want you to draw first the surface as well as the normal to the line. So draw the surface of the plane mirror. And of course, the most important thing is the normal line. The angle between an incident ray and the plane mirror is 40 degrees. So where does the angle lie? If it is between the incident ray, let's say this is the incident ray, and the plane of the mirror, meaning the angle is between the ray as well as the mirror. So angle given is 40 degrees. The angle of incident and reflection are, so what will be the incident angle as well as the reflected angle? Of course, you know this is 90 degrees, so you can minus 90 with 40 and be left with 50 degrees. And according to the law of reflection, the incident angle must be also equivalent to the reflected angle. Therefore, the reflected angle will also be 50 degrees. Let's go to the next example. A light ray is incident on a plane mirror. Determine the value of alpha. So how many surfaces do we have here? We have the first surface and we have the second surface. Of course, you have to draw the normal to the line for both surfaces and identify the incident as well as the reflected angle. Okay, so the first incident angle starts from here. The incident ray starts from here. So the incident angle will be between the normal line and the incident ray. So the theta here will be 90 minus 50, which will give you 40 degrees. So you know already 40 degrees here of the incident will be equivalent to the reflected. So here also will be 40 degrees. And the opposite angle, if you still remember what you've learned in school, opposite angle would be the same. So the incident angle here will be 40 degrees as well, but they do not want the incident angle, they want the value of alpha. So 90 minus 40 will give you 50 degrees here. So the value of alpha will be 50 degrees. So try to find another exercise, or you can also do the tutorials to get more practice on this. Let's go to plane mirrors. What are plane mirrors? Basically, plane mirrors are what you use every day in your daily life. When you want to see your face, or if you need to do your makeup, or even just looking at the mirror to see yourself, okay, those are called plane mirrors, where the surface of the mirror is very smooth. So the surface of the mirror is very smooth. So just go to the mirror right now. What I want you to do is go to the mirror right now, or open your camera and look at your face. Just imagine that is your mirror. Okay, so what kind of image do you see? Does it become bigger? Is it inverted? Or is it virtual or real? So those are the three criteria of images. For a plane mirror, the image is always the same size. For example, let's look at the candle here. Let's say the height of the candle is HO. Now, the image that you see on the mirror will be HI, which is also the same height as the object. And the object distance is also equivalent to the image distance. If you don't believe this, go and try. Stand in front of the mirror and walk backwards. You can see that your image is actually the same distance as well as compared to the distance you are standing from. So if let's say you are standing 1 centimeter from the mirror, your image is also standing 1 centimeter from the mirror. So that's what it meant by the distance of the images is the same as the objects. Also, the image that you see are virtual and upright. It does not become inverted, but the image is not real because it's behind the mirrors. Okay, now of course, if let's say I have an image that is not using a mirror or a different type of mirror that magnifies the object. So how do I calculate the magnification? This will be the equation which is m is equivalent to height of image divided by the height of object. So if let's say I am 165 centimeter tall, I'm standing in front of a plane mirror. Supposedly my image would also have the same height. So let me calculate them. HI over HO. So my magnification will be 165 divided by 165. This will give me 1 time. Meaning the image is the same size. But if let's say my image is more than 1, which is 3 times bigger. Let's say it's 3 times bigger. This means my image is magnified, and since it is in positive value, it means it is upright. So positive or negative indicates whether the image is upright or inverted. Terbalik lah. Okay, so for inverted, the value would always be negative. For upright image, the value will always be positive. Like I mentioned just now, if it is more than 1, it is bigger. But if the value of magnification is less than 1, which means the image is smaller.